Thanks, Jennifer. Hi, my name is Scott Smith. I'm the lead for NASA's Nutritional Biochemistry Laboratory. Jennifer provided you some great background information on the importance of good nutrition. Based on the information she provided, can you come up with a definition for nutrition? What is your daily nutritional need for calcium? How are you meeting that need? In your groups, take a few minutes to answer the questions. Your teacher can now pause the tape so you can collaborate with your peers. Nutrition is the study of how the body uses nutrients, like calories, vitamins, and minerals, and how much of each of those nutrients the body needs. While good nutrition is important for everybody, NASA scientists at the Nutritional Biochemistry Laboratory look at how astronauts' nutrient needs are affected by spaceflight. One area that is very important is the role of nutrition in keeping bones healthy. Not eating foods that include nutrients such as calcium and vitamin D can result in weak bones. You can find good sources of calcium and vitamin D in dairy products such as milk and cheeses, broccoli, and spinach. Calcium is probably the most important nutrient when it comes to building strong bones. More than 99% of the calcium in your body is stored in bones, and when you don't get enough calcium in your diet, it comes out of bones to help the other tissues. If you do that long enough, what happens is the bones become weak and brittle and can lead to diseases such as osteoporosis. Osteoporosis is a disease where the bones become fragile and break. The best way to counteract or prevent getting osteoporosis is to eat well and exercise when you are young. So why are we concerned about bone loss during spaceflight? Astronauts actually lose bone mass during spaceflight. This is especially significant for long missions, such as the astronauts that serve on the International Space Station or on future missions to other planets. When astronauts return from long missions, they have an increased risk of fractures and other health problems because they lose bone mass and calcium. Do you have any idea why this occurs? Does that mean they get osteoporosis while they're in space? The human body gets used to operating in Earth's gravity field. When humans are removed from this environment, as when they travel in space, many complex changes take place. While living and working in a microgravity environment, your body senses that it doesn't need as much bone mass to support the body, so bone mass decreases. When you return to Earth's gravity environment, your body senses it needs more bone mass to support the body, so bone mass will begin to increase. Because it takes a long time to regain the lost bone, this is the period when you have a higher risk of bone fractures because your body's skeleton has a tougher time supporting your body against Earth's gravity. Here at NASA, we conduct research to understand how much calcium is being deposited into bones and how much calcium is being taken out of bones. This research involves mathematics, especially measurement and estimation skills. For example, let's take a look at the following system diagram. Suppose Norbert was to consume 1,000 milligrams of calcium, which is the daily recommended allowance, in the form of a large glass of milk. This diagram shows the path that calcium and other nutrients follow as they enter Norbert's body from the mouth. The milk enters the stomach and is broken down in the stomach and small intestine by chemical processes. Approximately 80% of the calcium, or 800 milligrams, leaves the body as solid waste. The remaining 20%, or 200 milligrams of calcium, enters your bloodstream. The calcium will help many of your body functions and, importantly, will prevent calcium from being taken out of bones. This is what happens when you don't eat enough calcium. About 5%, or 50 milligrams of the remaining calcium, enters your kidneys and is released as liquid waste. Some of the calcium will be taken up into bone, and some will also be released by bone back into the bloodstream. Finally, a small percentage of calcium flows from the bloodstream into the large intestine and out as solid waste. To estimate how much calcium bones are absorbing and how much calcium is being taken out of bones, we can give Norbert a tiny amount of a special form of calcium. For this case, let's call it blue calcium. Over time, usually 10 to 14 days, we collect biological samples of solid waste, liquid waste, and blood. We can determine how much calcium, regular or blue, is in each sample. By mathematically analyzing the data, we can actually estimate the amount of calcium absorbed by the intestines, how much calcium is filtered by the kidneys, how much calcium is being deposited into bone, and how much calcium is being taken out of bone. By studying the flow of calcium before, during, and after spaceflight, we can tell how the body is changing during flight and what is happening to the calcium. From our estimates, we can conclude that the amount of calcium that is deposited in the bone and the amount of calcium released by the bone back into the blood is about the same. This changes when astronauts are in space. The amount of calcium absorbed by the bone is less than the amount of calcium released by the bone. Finally, when astronauts return to Earth and recover over time, the amount of calcium deposited into bone and the amount of calcium released by bone stabilizes and returns to pre-flight levels. Understanding the specific means of how bone and calcium use change during flight can help us figure out how to counteract it and also help prevent bone disorders on Earth, such as osteoporosis. Are you beginning to understand the importance of nutrition and how nutrition can be important for your health? Have you changed any of the answers to the questions I asked earlier? Now would be a great time to stop the tape and review your answers.